everyone. This is the class for, oh goodness, when was this? July 17th. This is the 11 a.m. class. This is the algebra pre-algebra. We are going to start with this problem, x minus 3y plus 6 equals 0. And we're going to graph this. So by now you should be able to do this. First of all, we want to think about what form are we trying to get it in. And you should know that by now, okay? The form we are looking for is y equals mx plus b, okay? That is slope intercept, okay? We've talked about that the m is your slope and the b is your intercept. And those are the points that you're going to put on your graph and graph with. Now, if you're not comfortable with that, you may do a table, but this is where we want to head to, okay? So the first thing we're going to do is solve for y. So go ahead and push pause and try that out, and then come back and watch. All right, so we're solving for y, which means we have to get the x term to the other side. It has to cross the street, okay, right there. We also need to get the number on the other side. I'm going to start with a number, no reason. You could have started with your x, but that's what I'm going to start with. To do that, I'm going to do the opposite. So I'm going to subtract 6 from both sides. Okay, so now I've moved that 6 to the other side, and I have x minus 3y equals negative 6. Okay? I'm still solving for y, so now I'm going to move the x term to the other side. To do that, I'm also going to add the opposite. The opposite of a positive x is going to be minus x to both sides. Okay? Now, because I know I want it to be y equals the x term, I'm going to write that x term first, so that it looks like this right here, and then minus 6, okay? Now, I want my y alone. This is where we separate. So this is like separating mom and dad, okay? This is more than just moving it to the other side. Here this says negative 3 times y. We're going to do the opposite, which is divide both sides by that negative 3. But I'm going to put it under each piece so I don't forget it, okay? That leaves me with y equals negative divided by negative. It's like it's magnetic and it has turned into a positive. So it is now, couldn't we say there is a 1 in front of that x? Right? It's that understood 1, understood u. So this is really 1/3 x, and then negative divided by negative again is positive. 6 divided by 3 is 2. So now I have this solved in slope-intercept form. That means my m is right here, the 1/3, and my b is 2. The b tells me this is my y-intercept. That is the point where x is 0 and I have my y value, my b value, or in this case 2. So I'm going to put that on my graph first. So I have 0 in the x direction, but I have 2 in the y direction. That is my b value, or my y-intercept, because it's intercepting, it's crossing over my y-axis. Okay. From that point, I'm going to use my slope. Slope means rise over run. Okay, very important. So from this point, I'm going to rise 1, and I'm going to run 1, 2, 3. So it looks like it's going to be right about there. that looks good, okay? Now, what if I wanted to rise -1? Can I do that? Yes, I can. So I can rise -1, but then I'm going to run -3. So that would put me over here. Sometimes it's easier than going up 1 and over 3 more. Okay? Sometimes it's easier to go up, sometimes it's easier to go down, but 1/3 means the same as -1 over -3, which would be the rise -1, run -3. Okay? Then 2 points make a line, 3 points we can check, so that's why we like to do that. We're going to connect these lines. We're going to put arrows on there because it is a line and it continues on. It does not stop. Okay? Now, we graph this using slope-intercept, which is where we want to get to. Okay? Again, if you're having trouble with that, you could have made a table of x and our y values. Our y, of course, is this equation here. We know we always like to put in x is 0 first. That means 1/3 times 0 is 0. 0 plus 2 leaves us with that 2. Okay. If I chose my x was 3, 3 times 1/3 is actually 1, and then 1 plus 2 is 3. And you can see that's the point here, 1, 2, 3, 1, 2, 3. Maybe I put in -3 for my x. 1/3 times -3 is -1. -1 plus 2 is a +1. And you can see that's the point here, 1, 2, 3 in the negative x, 1 in my positive. Okay, so whether you've done the table or slope-intercept, it will give you the same answer. Now, sometimes you're actually given something like this. The slope equals 4, and your y-intercept equals 2. And we want to write this equation. Well, how do we do it? It's actually quite easy because we already have all the pieces, okay? What we're going to do is we're going to put the 4 in place of the m, and we're going to put the 2 in place of the b. That means our new equation is y equals 4x plus 2. Okay? And you've just made an equation of a line. So let's go ahead and graph that. Points back on here. Okay, so there's our graph, and we are going to graph this. Well, we know our y-intercept, our b value is 2, okay? So that means 2 on the y-axis. So that point is right there, which is actually the same one as down there, okay? Now, our slope, our m is 4. Don't forget, that means rise over run. So since that equals 4, we can really put a 1 underneath it so that we know how many to run. So we're going to rise from this point, 1, 2, 3, 4, and we're going to run 1. Okay, that's our new point. Now, if I keep going up, that's really, really high. So what I want to do is, I want to rise -4. So how many am I going to run? Sure, you're going to run -1. So now I'm going to go from my B point, I'm going to rise -4, 1, 2, 3, 4, and I'm going to run -1. Okay, that's much more manageable down here than way up here, which is why I chose to do that. Again, 2 points make a line. 3 points, we can kind of check it, make sure nothing's out of whack, as I like to say. And my line is not that straight, but anyway, there's our line. Okay, we can see, again, we read from left to right, so we can see we're going uphill. Can you see it's really steep though? That's not quite a hill that you'd want to climb. Okay. So that was some more of the graphing. We actually combined the classes, so make sure that you watch the 10 a.m. from about 10:31 because we already practiced solving some equations there. Okay. All right. Let's get us a clean board again. Else you might be asked to do, and we've not done this yet, so this will be the first time, so just you can write all this down. If our slope equals -2, and we have a point 4, 5, we want to come up with the equation of our line. So we still want to do y equals mx plus b. Okay, so we're given a little bit different information this time. Now, that point we are given, don't forget, that's an x and that's a y. Okay, so in our equation, we have y equals mx plus b. Okay. What I'm going to do is I'm going to replace the m with what I was given, so -2. Okay, so that's putting in the x. I don't know my b. Okay. Now, what I'm going to do next is I'm going to take this point. It says my y is 5, and my x is 4. And then I still have plus b. So all I've done is I filled in the m, and I took an x and y and I put it in for x and y. Now I'm actually going to solve this for b. Okay? First of all, we have to simplify. So -2 times 4 is -8 plus b equals 5. Okay? I want to solve for b, so I have to move that -8 to the other side. So I'm going to do the opposite, which is plus 8. To both sides. Those 8's cancel out, leaving me with 5 plus 8, which is 13, and that actually equals my b value. Now I have my m and I have my b, which is exactly like what we did over here. So my final equation is y equals m, so -2x plus my b, which is 13. Okay? Now that b is quite large, so that would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, way up here. But our slope is negative, so it would come down to run +1. So it's a little bit big. I'm not going to graph this one, but you could. Okay, so like I said, we've not actually done this in class. This is the first time bringing it up, so we will practice it a lot more. But you can see it kind of is the same thing as this, just a different piece we're finding first. Okay? Alrighty, ready for the next thing. Now we are going to do some FOIL. Now remember, FOIL is when you multiply what? Right, when you multiply binomials. Okay, it is a special algorithm when you are using the binomials. So, when I take x plus 3 and x minus 4. Okay, those are binomials. Okay, bi means 2, so there's 2. So 2 and 2, and we're multiplying those together. So go ahead and push pause and try this out on your own. Okay, so when you do this, we're going to use FOIL. We've done these a few times now. All right, so F stands for first, and that would be the x times the x, which is x squared. All right, our O stands for Alder, and that would be the x and the careful negative 4. So x times negative 4. Okay, that's negative 4x. Okay, I stands for inner, and that would be your 3 and the x. So 3 times x, and that's 3x. Okay. And then we will have L, which stands for last. And that's the 3, and again, careful, the negative 4. So 3 times negative 4, which is negative 12. Okay. Now, the next thing we do is we're going to add these all together. Okay. So the first term is x squared. Are there any other x squares there? And no, there's not. We only combine like terms, so just the x squared. The next one would be the x term, and I see that I have 2 of those. So negative 4x plus a positive 3x would give us a negative 1x. And again, that 1 is understood, so you're not supposed to write it, but it is there, okay? And then we have our negative 12, okay? We've talked about a few times this, whenever it has a square term, is a parabola. And since this is positive, it is a U-shaped parabola. Okay? All right, let's take a look at this one. So this is a rectangle, side of 2x, side of x squared plus 4x minus 2. Okay? I want you to find the perimeter. Okay? When we find the perimeter of a rectangle or of anything, we're actually adding up all the sides. It's like you're painting the walls. Okay, so we need to touch each one, but we're adding those. Okay, so I'm going to start here, and I have a 2x. Okay, then here, now I'm going to line these up. I see there's a 4x here, so I'm going to be careful and put these two together. Then there's the minus 2 and the x squared. Okay, you always want to line things up. Then this would be another 2x, so I'm going to put him up here. And then I would have another x squared plus 4x minus 2. Okay? Now, when I add this whole thing up, I only have in this part here a minus 2 and a minus 2, negative 2 and a negative 2, which would give me negative 4. I can't put that with the x's or the x squares. They're different things. Okay? Then I have 8x, 10x, plus 2 more is 12x, because those were all like terms. So I can go ahead and add those up. And finally, I have an x squared and an x squared. Okay, so it's going to remain an x squared. It's like an apple pie plus an apple pie. How many apple pies you have? You have 2. But they don't change. They're still apple pies or x squares. So this would be the perimeter, because what we've done is we've added everything up. But we were careful to line up the like terms, okay? These things were like terms. They were each in a column. It's almost like you're thinking ones, tens, hundreds. They each have their own column. Okay, so that's what we've done here. Now, I would also like to find the area. So let's take a look at that. The area of this, the area of a rectangle, and we've done this in classical, is length times width. So that means 2x times x squared plus 4x minus 2. Now, do we get to use FOIL on this one? Nope. Do we have a binomial here? No, we don't. We only have one term. One term is actually a monomial. So this is a monomial. Okay. This has 3 terms, which means it's not a monomial, it's not a binomial, but it is a trinomial. Okay. So no, we do not get to use FOIL, but what we are going to do is we are going to use the distributive property. Okay. So we're going to take that 2x and it has to touch the x squared. When I say touch, it means it's multiplying. Okay. Then the 2x has to touch the 4x, but we're going to keep that sign. So now we have 2x times the 4x. Okay. And then we have the 2x needs to touch the negative 2. Again, bring the sign down. Now we have 2x times the 2. Okay. Again, we're not done. We actually have to work this out. Okay. So x times x squared. So this means there's 1x here and 2 here. That means that we have a total of 3 x's, or x cubed, and the 2 is still there. Keep the sign. Now we have 2 times 4, which is 8. X and an x, that's x squared. Again, keep the sign. And now we have 2 times 2, which is 4, and our x. Okay. So we've done FOIL, we've added them, we've also done distributive property. Okay, those are all things you would do. You have monomials, binomials, which we did the FOIL with, and trinomials. Okay, this curve, because of the cubed, would actually be something like this design. Okay. This one with the square and being positive is going to be your parabola. And the first shape we looked at was the line, which is our y equals mx plus b, and those are linear equations. Okay. So there you go. I will see you on the 24th for our last summer lesson. We will do quite a few more of these, so this is brand new, so don't worry, but you got to watch it so that you're beginning to understand how it works. All right, see you next time. Bye.